Is it a me issue? Can you hear me? Not if you can hear me.
Here, can you hear me now?
Okay.
It's
Oh!
your
It was me! My bad!
okay. Well,
Sorry.
Hey, boy, you stupid.
Hey,
I think we're good now. So we've got a pretty good turnout. We've got 2 more people that are on their way. So
good.
Let
me see.
We also had a couple that have to work, so they've asked that we record it. So we are recording.
Okay. Oh, my bad. Let me see. Show me the people.
How you say your last name? It's 2 R's, right?
Terrel. Yeah, that's right.
Put it in apostrophe. You say. Perfect. I do need to plug it up.
All right, everybody. So we're gonna go ahead and start our meeting. So it's great for all of y'all being here. I think this is one of the largest meetings our team's had since like 2012. So that's really great. Yeah, I can talk a little louder. So I'm really glad, and we got a lot of new faces. We have more new faces than we have returning faces. So really great on y'all. So I guess the first order of business I've been trying to talk to a lot of y'all to come in is getting those safety quizzes done. It's not a really big deal if you're here now without having them done. It's just we can't have y'all doing anything necessarily like hands-on lab work. But if y'all get those done, then we can get you like doing wet lab even quicker. But good on y'all for still coming because we got a lot of other important information that we want to discuss. So that's we're gonna just introduce ourselves again. So I'm Ian Terrell. I am the 2020-2021 car team captain. So this is my 3rd year in car team. So I'm really happy to take over as captain and try and be us forward. We also have Larson and Kashan, who are going to be our co-captains for this year. Other thing we're going to try and announce is this year we are working on having 2 teams, and with the membership we have here tonight, I think it's more than achievable. So what I mean by 2 teams, one, we're going to have a team working on the current car. So what we're planning on competing with in the spring and in the in the fall, and then nationals of next fall. And then we're going to have a second team that is going to work on developing reactions and a car to use in the next year. But I will say, if we make leaps and bounds, like I know that we're all capable of, I'll make this pledge that we will send a second car if it's ready. We'll have 2 cars at regionals. So that's something for y'all to look forward to. So even if you end up doing the second car, don't feel like, oh, I won't get to compete with this right now. If y'all do well with it and it works out real well, then we'll definitely compete with it as well in the spring. So just want to bring that up to y'all. So one thing I want to start up on tonight is I'm going to try and go through some wet lab. So we're going to try and do the iodine clock reaction. So that way everyone can kind of see how that works and then see how we try and run our labs here. And then I want to power up the stopping reaction. There's not as much wet lab with it since we will just be putting chemicals and putting it up to a power supply and charging it. And then if everything goes well tonight, then we will actually try and run the car this evening so everyone can see it in operation. Yes, Russ? I have LEDs, since that's what you're going to try and do. So there's the chargers over there with the chemicals. Yeah, I'll show. Yeah, it's so go my car team. If you want to see so, by the way, this is Andrew. So he's a mechatronics major that's going to try and work with us on our electronics and mechanical side. So he said you needed help. So does anyone have any questions before we kind of get started? Yeah, you can sit like right in that yellow chair, or if you want to sit right here, you're more than welcome to. They're just moving around. It's fine. So just to kind of go through, since we do have a lot of new faces. So what car team is, I'm gonna So what car team is we design a car, which you can see two examples of cars we have designed in the past sitting over there. So we design a car that is powered by a chemical reaction and then stopped by a chemical reaction. You're welcome to come on. What's your name? Justin, how about you? Messaged me and the group you sent. You're on your way, right? Yeah. Well, that's fantastic. All right. So, one thing tonight, what I want to try and do is also like introduce everyone so we start getting familiar with each other, because we're not only just like seeing each other a lot in here. These are people in the same major that we'll have experiences with like throughout this year and later years. So it's good to go ahead and know each other. This is a great way of doing it. It's one of the benefits of car team. But back to what car team is. So we build a car that is powered and stopped by a chemical reaction. But we also do a lot with the electronic side of like writing a program and running this car to like interpret these signals we send to it from our reactions. But we also have mechanical aspects we have to do, such as like a drivetrain, as we have in the first one. What is it called again? It's slipping my mind. The Eagle engine. The Eagle engine uses a drivetrain and a single motor with a double shaft. And then we thought mechanically this past year it would be a better idea to run with a single wheel on the back. So it's actually only has 3 wheels with the same stability. So there's a lot of like different aspects outside of chemistry. So if y'all aren't like super big fans of chemistry, then there's other things you can do with car team, but there's also plenty of chemistry. So, great. Does anyone have any questions so far? Nick, do you want? Yes. Okay. So in the GroupMe, I put in a link to some safety quizzes, and then what safety quizzes you have to take. I'll send that out again tonight, so it's like fresher in the feed. So you have to do that before we allow you to mix chemicals, since we don't have like certified TAs in here. We're all kind of have to share responsibility for our lab safety. So as part of like our safety procedure, we want everyone to be up to date on these safety procedures. So you have I would prefer that the safety quizzes be done by everyone, so that way there's just no limitations, and then that way you're also a lot just safer in the lab. If something does happen, you know what to do. It shouldn't take you very long. So, and if you'll have any questions about that, just talk to me afterwards, and I can make sure that I clarify which ones you have to take. They're pretty straightforward. The first time you take them, they might take a little bit longer. Just you got to learn a little bit of new stuff. But for all the chemical engineers, these are things you will have to take continuously as you're in the department, and they're good for 1 year. So it's a lot easier to take them now, get like used to the information. So that way, when you have a deadline, like your freshman or junior year, where it's like, get these safety quizzes done in the next week, so that way you can be in lab. It's like, oh, I just have to go through and update my quizzes, and I don't have to like sit here and try and learn all this new information. So it's a great thing to go ahead and do. So don't let that like be like, oh, this is a lot of work to put in like right off the bat. It's something that will benefit you in the long run. So is there any other questions? So Nick, if you can go ahead and like power up, trying to charge the battery. And then Will, if you can start trying to set up the stopping reaction. And Gabby, if you can help him too. The chemicals are right over there in the back. If you have any questions, I have keys to glassware if you need anything too. So, yes.
Are the quizzes similar to like the quizzes you take to get into like the library?
Yes, they're the exact same quizzes.
Hey, Will, can you hear me? Will, hi.
What up?
Hey, do me a favor, and with the stopping batches, make sure they're correctly labeled for me, please.
What?
Relabel them for me, please.
Oh, no, it's
Each of the containers that are over there with all the chemicals in them and stuff?
Yeah, so like the sodium metabisulfate, potassium iodate, and starch, if they're not clearly labeled, relabel them for me, please.
All right, gotcha.
responders should still be updated to the 16th. All of our sales for them. So that's when all of ours expire. So while they're getting that set up, so we can show you all kind of like our reactions. One of the things that I would like really emphasize is if you have any ideas whatsoever, feel free to blurt them out, because like we only have our experience that we built off of. So like y'all have got like 18 years of completely different experiences of ideas that we might have never thought of. So like a couple of things we've done in the past is like we have a battery right now. It's a lead acid battery, or it's a lead ion battery. It's like a derivative of a lead acid battery, which is like an old car battery. A lot of car batteries still use that. So if you have other types of batteries that you'll think that might work better, then like definitely talk to us about, and that might be something that we want to jump on board with. The other thing is we've used thermoelectric generators before, and so one thing we found is they just weren't efficient. But that's like something that I had never thought of coming here. That was what we did my freshman year. And we had people that suggested the battery that year, and we ended up not going with it, but the battery was the much better item or way of doing things. So don't ever be afraid to like say an idea, even if we don't roll with it at first. If like do some research on your own to it, and like definitely try and present it to me, and because I'm more than willing to definitely look at different options. And that's also the thing that's really great with having this many people, is I can say, oh, this looks really great. Let me know what you need, and then I'll get you with someone else that's interested in doing it. And both of y'all will figure out time to get you lab space to try this with our team. So if you have any ideas, just talk to me about it, or any one of our co-captains or the team leads. That'd be great. I guess our next order of business is we really need, I was hoping tonight to select a car team chair. So what this person would do is they would, so a car team chair is like an officer position on AICHE, but their main purpose is to relay like car team information. So, hey, we need more funding. Hey, we need to look at trying to get like a bigger lab space. We need a faculty advisor to help work with us on this safety procedure. So it's a really great way of like connecting us with the rest of the department instead of us kind of being like a floating entity. So I was really hoping for like a freshman or a sophomore that was interested in this, because this is a position that we're looking at like you could continue to do this, or this could be your stepping stone into becoming co-captain, captain, or team lead. But it also like gives you like that repertoire with the rest of the department. So then like that way, when you're at my position, you're not trying to like make friends with the people that you need to make friends with. You already have that, those like knowing each other. So there's like anyone interested in that position. Like this isn't like, all right, that'd be great. And I'll talk to you afterwards. If anyone else is interested, just let me know. And we can talk and see. Yes. Huh? Yes. So we still have the other lab, but with so many people, we can't have that lab right now. So, where's the power? Oh, we haven't slept on this.
Okay, because they need a fix it.
What's wrong with what bounding box? We can take it apart to hit on the box. So we're good. Yeah, we're good. So the other thing is we also have a couple other positions. These aren't as crucial to get filled, but one of them is I was hoping to have a secretary, so someone that's not necessarily responsible for writing everything down, but making sure everything gets written down. Because it's one thing, we don't know a lot about car team between 2011 and 2017 because there isn't any documentation of it. There was a car team. We've had a car team they met, but they might only have met like 6 weeks and then stopped. So that's one thing I want to make sure that we have is documentation. So that way when y'all are seniors and you're looking back on our team and you're like, what did they do 2 years before I got there? And you can't remember. Then you have the documentation that we laid out my freshman year for y'all, so y'all have it your junior and senior year when there's no one that worked on that car still here. So I just want to put the secretary in charge of making sure that each team writes down any progress they have or any issues they run into. So that way we do have information for y'all in the future. So that's something we're going to talk about at a later date. But if you're interested, then feel free to go ahead and talk to me about that. That's a great thing to add to your resume because it's like leadership experience, and then also it shows good note taking and good diligence. So it's a great way to build your resume as freshmen. Oh no, it's in that red. Yeah, it is. I'm in solution of what we did in the lab. I don't know what it is off the top of my head. It's marked down in notes. Okay. So, is there any other questions anyone has? So, I guess I'm going to kind of go in depth about what each team does while we get things set up. I know a lot of y'all have like heard this before, so if you want to like touch Sean or Larson, if you've heard a lot of this, or if you have questions, feel free to ask. Let's go in first. We'll talk about the stopping team. So their priority is to design a stopping reaction that sends some sort of signal to the car, the like Arduino, the computer board, to tell it to stop, or to tell the motor to stop moving. So we can't physically stop the car with any kind of like mechanical force, but so what we have to do is we have to tell the motor to stop spinning, even though it still has power going to it. So a couple of these concepts that we've like thought of before or seen other teams use is like you use a pressure reaction that slowly builds up pressure that has like a linear progression. And so then what you have to do is figure out how long you want to run it. And then you just set your computer to once it reaches that temperature with like a temperature gauge, then it'll tell the car to stop. So that's one way we can go about doing it. We currently are using an iodine clock reaction, which is like a kinetics project. You'll learn a lot more about it, I think, like in the last chapter of Gen Chem, and then also when you take kinetics here. But it's concentration that when you adjust the reactions of the components, it will go from clear to black at different intervals of time. So how we use ours is we change the concentration of potassium iodate in solution. So that way, when we have like a smaller amount, it can take up to like 5 minutes for it to react. And then when we use it like in 50-50 amount, it can take like 3 seconds for it to react. So one of the big things that stopping team's going to be doing in the near future, or at least one of the parts of stopping team will be doing, is they're going to be measuring out all these little increments to figure out, like, say we need to move the car for 1.5 minutes. They know, oh, then we just have to do such and such concentration, and they're going to have a chart, and they just have to, like a graph in Excel, they just have to go and follow the line and be like, okay, here's how long we have to run. So that's like the goal of stopping team. So like I don't know, like the coup d'etat of like the stopping team would be like, they have it down to like for every second they know what concentration they have to run. So we're stopping the car within like half an inch of the line that we need to stop. The next is power. So this is one of the, so stopping is one of the ones where you have more work towards the back end of it. Power is the most in towards the front. So it's finding a reaction that reliably gives enough electrical energy to move the car, because it does take a bit of energy. So it's finding a reaction that will do that reliably is a bit of a challenge. This is with our thermoelectric generators. We found that they are not a consistent form of energy. So you have some that will give like a great electrical charge and it'll move a car. But there's some that give like 0.1 joules per second, which is horrible. And that won't even make your car budge. So that's what we want with the battery, where we're able to like really, I think I don't know what our current output of the battery is. I have no idea.
The old one was approximately no power, lead acid battery. I think we got like, what was it, like 3/4 of the way around the building?
So yeah, so our current battery will move the car 300 feet per charge, 300 plus feet per charge. And that charge is about a 45-minute time span. That's the last time we were able to test it to our full. My new estimate of if we charge it for an hour, which is our max charging time, I think we can move it about 400 to 500 feet because we've added in meters. Oh, that's like it's like 100. It's a little over. It's about 125 meters, I think.
So about 4 times the distance.
Yeah.
Okay, so we
Nick has them. Yeah, he has the lab. Yeah, I just had it in my feed. He went out to the lab.
No.
He should be back down in a minute, though.
If he's actually going up there, I could actually run over.
Oh, that works too. So yeah, but our thermoelectric generators wouldn't move the car at all. The next team is electronics. So they do a lot of our electrical work. So programming the computer, selecting the parts, figuring out LEDs, wiring it up. The big thing is like putting in like stopping buttons, safety procedures. They'll put in sensors, so they'll have to put in a pressure sensor if it's like a pressure stopping reaction or a pH sensor. In our case, it's a photoreceptor that will tell the car to stop once. Like there's a baseline, and once it goes like this amount of light going through, once that baseline is hit, then it will tell the motor to stop moving. And then chassis. So chassis is one of those for you to be creative because you're going to be designing our car. So this is one, if you're interested to running like 3D printing Inventor, then Russ is offered. He's going to help like teach y'all. I've learned a bit of 3D printing and Inventor to work like with Power Team and stuff with designing our casings. But he's going to like show you how to design, like if you look at our most current car, we have the button mount. So Russ designed that, as well as the big black box on the end. That's
for the power part, what is in one model.
Yeah. So Russ designed the wheels, the mounting brackets. So these are, yeah, the button, this
Big part on the left.
and then like what holds our stopping reaction in there. So that's what you're going to kind of do on the chassis team. Also, like when like you come to me whenever you decide what team you're interested in, you're not locked down in that team. If you go through and find out, hey, I actually don't like working with the power reaction, it's not quite what I thought it would be, then we're more than happy to help move y'all to a separate team. Or if I don't expect anyone to do this, but if it gets to the point where it's like, I want to work on 2 teams. Like I want to help with designing of the car, but I also really like with the power, and that's also an option we'll be more than happy to look at. And one thing I will say about like stopping and electronics, in the past they've really gone hand in hand, not stopping electronics and chassis, they've gone really hand in hand because they use similar skill sets with like working with computers. So that's also something to keep in mind. Like in that case, that's the easiest one to do both. And because your meetings tend to like be the same. So like Russ in the past is running electronics and stopping, electronics and chassis. They've had the same meeting times. So is there any questions about that? If anyone's like got any chemistry questions too about the chemistry of any of the reactions, I'm happy to go through that now. But if no one's like super interested in that, okay. So I wish I had chalk, but so how the battery works is we have that's not really the same. So we have lead plates, and so we have a power supply. We have lead plates and a magnesium sulfate solution. So it's like I think it's like 0.5 molar sulfate solution, or it's like 1.5 molar sulfate solution. I can't remember exactly which one it is. I've got it written down up in our lab. But what it essentially does is, as we send electrical current from a power supply into our battery, then it kicks off ions from the battery. It's like a galvanic cell that you'll learn about in Gen Chem. And so it'll send it to another battery, to another plate that acts as, so you have an anode and cathode. So the anode will kick it off and then they'll transfer it to the cathode. But it'll hold some of these ions in solution. So the sulfate ions stabilize these negative lead ions in solution, which allows us to hold a charge. And so after we charge it for like 45 minutes, then we have X amount of negative lead ions in solution. So then when we transfer it to then when we plug it up into the motor, those ions will continue to transfer over to the next plate, sending that electrical energy to the motor to then use to turn the car. Does that explain kind of? Yeah, it's one of those things where you have to like really look at galvanic cells, and you have to like look at the math. It's a bit more math heavy to go into like detail, but that's kind of like a general concept idea of it. Yeah, it functions like a car battery. Yes.
How does the thickness of each lead panel obviously thickness of the volume of the liquid?
So this is one of those things I have to relook at my notes because I haven't dived into that math in like that's 7-8 months now. Yeah, so surface area of the lead plates affects the volts. The mass of the lead plate affects the amps that goes through. And solution, as far as we found, that like volume of solution doesn't have a huge overwhelming factor to the power like supply of the battery. I think like you do get a bit more of like a supply energy stored, but you won't have as good of a like transport or output. So what we found is like the perfect amount to store it well, but in which case that we still have enough energy to move it in the speed in which we have to move it by. So to kind of like clarify a little bit more of that. So in competition, we're given 2 minutes to move a distance that's told to us at the beginning of the competition, carrying an amount of weight that's also told to us at the competition. So one thing we found is with this particular,
Between 15 and 30
Yeah.
meters and 250 and 500 meters.
Yeah. So we found is with our current design, our car battery weighs about 8-10 pounds. So no matter what amount of water we add, it doesn't affect our time just because of the sheer like power that our car turns at. So in this case, it's just our only variable is the amount of time it takes to move from point A to point B. And so we know that our car moves, will pass 30 meters, which is the max distance, in less than 2 minutes. So we're good on that, if that answers. We don't have to go to the tangent, but. Okay, that's good.
What is the budget? How much normally is across cost?
So budget's a little fickly right now. One thing I'm looking at is I'm looking for us some sponsors. The biggest thing is like with COVID, they're afraid like if we don't compete, it's like they're not as open to sponsor us. So we have regionals. So Will, myself, and Nick, we've been working on the car for a while. So we'll be competing virtually at regionals. We're going to compete this past spring, but it got moved to the fall because of COVID. Once we qualify there, I'm hoping to ask for like $1,500 for the car from some different sponsors we have in mind. Right now, our budget runs about $200 to $300. We get some more funding, like when it gets down to it, like our power supply costs like $70 because it's just something is unavoidable. So we managed to get an exception made for that to go over like the original budget we were given. So it kind of really varies. They love to spend less than $200, I think is the goal. But as we need things, it's just sometimes it's not workable because at this point we have one Arduino Uno. We're gonna need a second one this year since we're gonna try and have 2 cars in the works. Yes. Oh, okay, yeah. We're not going an Arduino. We have a new TNC 4.1 for the Zoom call. So that's something we want to add. So how much was that again? It's fine, don't worry about it. But that's something that's been taken out of our budget we haven't had to deal with the past 2 years. So I'm not really super sure on our budget right now, but we should have enough money to do what we need to do. But we don't have enough money to drop like $1,500 on a hydrogen fuel cell. But Dr. Rice is saying that our budget for this year is kind of still up in the air because we have a couple of things we're having to purchase that we haven't had to purchase in the past, like a new computer board. But we're good on money. It's not like we have like $50 to make the car. But I was saying that we don't have $1,500 to drop on a fuel cell to just buy a hydrogen fuel cell outright. But Dr. Rice, who's a professor here, which I believe she's talked to the freshman class already, she does research on hydrogen fuel cells. So we're thinking about working with her to build a hydrogen fuel cell, which we build a lot cheaper than buying one outright. So that is an option that we're looking at. So if y'all are interested in something like that, also let me know, and then I'll keep y'all in mind if we go that route. So you're working on it? Okay. So talk to Kishan about it. He's excited about that. Is there any other questions? Okay, fantastic. So who's completing their safety quizzes? I talked to, yeah, they're good. Huh? You're done yours for the, okay. So, Will, do you want one of them to run it, or do you want to run it yourself, show them?
Literally, all that there is to do is just put 4 wheels of that into that thingy, and then put it in that small beaker right there, and then just roll it around.
You want to try?
Yeah.
All right, so if you just walk him through it.
All right. If everybody else just wants to see it, I don't know what your whole stance on the social distancing is or whatever, but if you want, you can kind of just get this little quarter circle around here if you want to see it. So this reaction right here, this is what we're using for our stopping rate, because as David told you earlier,
Battery here, it makes power. You got some brain box that does thinking. Whenever this is getting light through it, it lets power go from here to a motor with a gear train. Once this goes dark, it doesn't let light through. It passes the power to this relay and carries water. Yeah. So it's not like a race. You have to travel between 15 and 30 meters and aim for a specific distance. Our maximum time that we can drive for is 2 minutes, and we have to carry up to this much water, 250 to 500 milliliters. Or half, somewhere between. And we have to do that all in under 2 minutes. And stop whatever this is working. So you could do this all with just analog circuitry, logic gates, but this is a lot easier because we can also have, where's the power for that? It has to be powered by a chemical reaction, and stopping is the Einstein clock in here. And what we have is light getting through the top of this. We have a light sensor down here, which you can actually read when it's reading that bottom. That's how many lux. Millivolts is power to
Hey, Manny,
battery.
are you still there?
Oh, hi, Manny. But you hold this down, it goes into priming.
I'm going to go ahead and end the meeting here. So that's like kind of the end of the informational stuff. So I'll talk to you tomorrow.
Or
I'll see you.
If things go